Okay, so today we're gonna go over the questions from last week. Number 1 says, using the following equation, determine the amount of moles of copper 2 chloride. So copper 2 chloride, they're asking us for moles that will be produced when 3 moles of copper react with oxygen. So we have 3 moles of copper. Okay, so in this question, they're giving you the information in moles, and they're asking you to find the information in moles of another compound. So they're giving you the information of moles of one compound, and they're asking you how many can I make, how many moles can I make of this product. Okay, so we're going from moles to moles. Remember that the first thing we always do is write what was given to us. 3 moles of Cu. Now, in these type of problems in stoichiometry, we always have to use a mole ratio, because a mole ratio is the only thing that we can use to go from one compound to the next, okay? Because this balance equation gives us the recipe of how many ingredients and how many products we're going to be able to make. Like, for example, if your cookie recipe tells you need 2 eggs to make 12 cookies, right? If you want to make 24 cookies, right, you want to double the recipe, you would need to add 4 eggs. And that 2 and 4 comes from your balanced chemical equation, or the recipe. So we're going to use this mole ratio to see how many coppers, 2 moles of copper for every 2 moles of copper to oxide. So the next step, since we're already in moles, is we're going to use the mole ratio. Let's do it in black, I guess. So we have 2 moles of copper. We're going to write that in the bottom, so the moles of copper cancel out. And in the top, we're going to write the moles of whatever compound is it that the question is asking us to find. 2 moles of CuO. In this case, since the question is asking us for moles, the only unit that's uncrossed is moles of CuO, and we're done. The only thing we have to do now is get our calculator, multiply and divide. So we're going to multiply everything on top, divide by the bottom. 3 times 2 is 6, divided by 2 is 3. So for every 3 moles of Cu, you're going to have 3 moles of CuO. And that's my final answer. Now for number 2, it says, when 4.6 moles of water, so 4.6 moles of water decomposes, so it breaks up, how many grams of oxygen will be produced? So how many grams of oxygen will be produced? So this question, the information is be given to us in moles, and they want us to find the grams of another compound. So we're going from moles of one compound to grams of another compound. So the first thing we're going to do is we're going to always write what was given to us first. 4.6 moles of H2O. Okay, remember in these type of problems, you have to make sure that you write everything out. Remember that you always want to write the mole ratio, but in order to write the mole ratio, you need to be in moles. And the mole ratio, you look at the coefficient that tells you how many moles of water, 2 moles of oxygen do I need, am I going to make. So here the ratio is, I need 2 moles of water. I'm going to write them in the bottom. 2 moles of water for every 1 mole of oxygen. If there's no number in the front, that means that there's a 1. Okay, and the reason that I put moles of water in the bottom is so that moles of water and moles of water cancel each other out. By using the mole ratio, I am now left in oxygen. But remember, the question is asking me for grams, not for moles. So I need to do one more step in which I go from moles of oxygen to grams of oxygen. And I do that by finding out the molar mass of O2. So in O2, I have oxygen. I have 2 of them. Each oxygen has a mass of 16. That's 32 grams per mole. 32.00 grams per mole. Okay, so now that number, in every 1 mole of oxygen, that has a mass of 32.00 grams of oxygen. last worksheet, I saw a lot of people putting in the bottom, instead of putting 1 mole, they would put whatever number was here. So whenever you're doing the molar mass, in the bottom is always 1 mole. You're only going to look at the coefficient when you're looking at the mole ratio, okay? But whenever you're looking at the molar mass, whenever you add up the masses of all the elements, in the bottom is going to be 1 mole. Okay, now I'm going to go ahead and cancel out moles of oxygen. Since the only unit that's not crossed out is grams of oxygen, and that's what the question is asking me for, I am done. So now I'm going to get my calculator, get 4.6 divided by 2 times 32, and that gives me 73.6 grams of oxygen. And that's my final answer. Number 3 says, using the following equation, how many moles of iron, so iron is right here, question mark, moles, are needed to produce 13.6 grams, 13.6 grams of Fe3O4. Okay, so in this question, they're giving us the information in grams, and they're asking us to find moles of another compound. So we're going to be going from grams to moles. Okay, the first thing we're going to write is what was given to us in the problem, 13.6 grams of Fe3O4. My next step would be to go from grams to moles, because remember, I always need to use a mole ratio in order to jump from one compound to the next. But in order to use a mole ratio, I need to be in moles, and right now I am in grams. So I need to find the molar mass of Fe3O4. Okay, so we have iron, we have 3 irons. On oxygen, we have 4 oxygen. We're going to multiply how many we have times the mass according to the periodic table, which for iron is 55.85, for oxygen is 16. I multiply 167.55, 64. I add them, 231.55 grams per mole. Okay, so now this number, I am going to write it in the bottom. Since I have grams up here, down here I want grams. So I'm going to write 231.55 grams of Fe3O4 for every 1 mole of Fe3O4. Remember, the molar mass is grams over 1 mole. Like this, grams cancel out. I am now left in moles. And now I could use my mole ratio to jump from one compound to the next. So my next step is going to be to use a mole ratio. I have 1 mole of Fe3O4 for every 3 moles of iron. Like this, moles of Fe3O4 cancel out. The only unit that's not crossed out is moles of iron. That's what the question is asking me for, moles of iron. So now my next step is going to be to take out my calculator and do this math. I'm going to do 13.6 divided by 231.55 multiplied by 3, and it gives me 0.176 moles of iron. And that is my final answer. Question 4 says, how many moles of HCl, question mark, moles, are going to be produced if 1.5 moles of AsCl3, 1.5 moles, react with H2S? Okay, so in this question, they're giving us the information in moles, and they're asking us to find moles of another compound. This type of question, moles to moles, is the easiest because it's only a one-step process. We only have to use a mole ratio. Okay, so we start with 1.5 moles of AsCl3. Remember that in all of these problems, we always have to use a mole ratio. And in order to use a mole ratio, we have to be in moles, which we are. So the next step is to use a mole ratio. There's 2 moles of AsCl3 for every 6 moles of HCl. 6 moles of HCl. Here the moles of AsCl3 cancel out, leaving the only unit uncrossed, moles of HCl, which that's what the question is asking us for. So we're going to do 1.5 times 6 divided by 2, and that gives us 4.5 moles of HCl. And that's my final answer. Number 5, part 8 says how many moles of water, so moles, question mark, of water will be if 9.63 grams of Fe2O3 react with hydrogen. So 9.63 grams. Okay, so this question is giving us information in grams and is asking us to find moles. So we're going from grams to moles. In these type of problems, remember, first we're going to use the molar mass and then the mole ratio. So first we're going to write what was given to us in the problem. 9.63 grams of Fe2O3. Next, we need to turn that grams into moles, so then we could use a mole ratio. And the way we go from grams to moles is by using the molar mass. So we need to find the molar mass of Fe2O3. We have iron. 2 irons times the mass of 1 iron, which is 55.85. That gives us 111.7. Oxygen, we have 3 times the mass of oxygen, which is 16. 3 times 6 gives us 48. We add them, and it gives us 159.70 grams per mole. Okay, now this number, I am going to write it here in the bottom. 159.70 grams of Fe2O3 for every 1 mole of Fe2O3. The reason that I wrote grams in the bottom is so they cancel each other out. Now that I'm in moles, now I could go ahead and use the mole ratio. So according to my balanced chemical equation, there are 1 mole of Fe2O3 for every 3 moles of water. Again, I'm going to go ahead and cancel out moles of Fe2O3. The only unit uncrossed out is moles of water, and that's what the question is asking me for. So my final step is going to be, I'm going to get my calculator, put 9.63 divided by 159.70, multiply that by 3, and I should get 0.181 moles of water. And that is my final answer. This is for 5B. I just copied the equation up here so I have it. The question says, how many grams of iron, so now they're asking me for grams of iron, will be produced if 0.59 moles of hydrogen react with Fe2O3. So they're giving me 0.59 moles. So in this question, in 5B, they're giving me the information in moles, and they want me to find grams. Okay, so this question is kind of like the opposite of the other one. The other one gave me the information in grams. They wanted me to find moles. 5B is giving me the information in moles, and I need to find the grams of another compound. Here, I would use the mole ratio first, then the molar mass. Okay, so I'm going to start with what was given to me first. 0.59 moles of hydrogen. Since I am already in moles, my next step is to use the mole ratio. So I could jump from hydrogen to iron. So I have 3 moles of hydrogen for every 2 moles of iron. Okay, I wrote moles of hydrogen in the bottom, so the moles of hydrogen and moles of hydrogen cancel each other out. After using the mole ratio, now I am left in moles of iron, but the question is asking me for grams, not for the moles. So I need to do one more step in which I go from moles of iron to grams of iron, and I do that by looking at the molar mass. I'll do it up here. So I need to look for the molar mass of iron. Okay, since I only have one iron, all I need to do is look at the periodic table for iron, 55.85, okay? And that will be 55.85 grams per mole. That's my molar mass. So I'm going to put that number in the top, 55.85 grams of iron for every 1 mole of iron. Like this, the moles of iron cancel out. Remember again that every time you use a molar mass in the bottom, you always have 1. Even though in your balance equation you have 2 irons, you're just looking for the mass of 1 iron. Okay, so it's 1 mole. So now since the only unit left uncrossed is grams of iron, that's what the question is asking me for. I am done. I'm going to get 0.59 times 2 divided by 3 times 55.85, and that should give me 21.96 grams of iron. And that's my final answer. Number 6 says if we want to produce 5.23 grams of carbon dioxide, 5.23 grams, how many moles of calcium carbonate do we need? Okay, so again, in this question, they're giving us information in grams, asking us to go to moles. So from grams to moles. Okay, so my first step is I'm going to write what was given to me. 5.23 grams of carbon dioxide. Now, since I am in grams, the first thing I need to do is go from grams to moles by looking for the molar mass of CO2. Okay, I have 1 carbon, 2 oxygen, 2 times 16 is 32, carbon is 12.01. I add them, I get 44.01 grams per mole. So I have 44.01 grams of carbon dioxide for every 1 mole of carbon dioxide. I wrote grams in the bottom, so the grams of carbon dioxide and grams of carbon dioxide cancel each other out. Now that I'm in moles of carbon dioxide, now I could use a mole ratio to jump from one compound to the next. Okay, so I have, according to my balanced chemical equation, I have 1 mole of CO2 for every 1 mole of calcium carbonate. The moles of carbon dioxide cancel out. The only unit left uncrossed is moles of CaCO3, and that's what the question is asking me for. How many moles of calcium carbonate? So I'm going to get my calculator, do 5.23 divided by 44.01 times 1 divided by 1, doesn't really matter. I get 0.118 moles of CaCO3. That's my final answer. Now 6b, it says how many grams of CO, so calcium oxide grams, will be produced if 5.93 grams of calcium carbonate. How many? 5.93. Okay, so now in this question, I did a different color so you can see the difference. The information is given to us in grams, and they're asking us for grams of another compound. This is going to be the longest type of problem because I need to do molar mass twice and the molar ratio. Okay, so first I'm going to write what was given to me in the problem first. 5.93 grams of CaCO3. Now the first step that I need to do is turn that grams into moles so that I could use a mole ratio. So I need to find the molar mass of calcium carbonate. Okay, so I have calcium, carbon, and oxygen. 3 times 16 is 48. The mass of one carbon is 12.01. The mass of one calcium is 40.08. I add them all up, okay, to find the molar mass. It gives me 100.09 grams per mole. So now I have 100.09 grams for every 1 mole of calcium carbonate. The grams of calcium carbonate are gone. Now I'm left in moles of calcium carbonate. Now my next step is going to be to use a mole ratio so that I could jump from one compound to the other. And here the ratio is 1 to 1. Okay, so I have 1 mole of CaCO3 for every 1 mole of CaO. The moles of calcium carbonate cancel out. I'm left in moles of calcium oxide, but the question is asking me for grams. So I need to do one more step, in which now I need to find the molar mass of calcium oxide. Okay, so calcium has a mass of 40.08. Oxygen has a mass of 16. I add them, and it gives me a total mass of 56.08 grams per mole. Okay, that number, I am going to put it in the top now. It says I have moles of calcium oxide up here. In the bottom, I want 1 mole. So for every 1 mole of calcium oxide, that has a mass of 56.08 grams of calcium oxide. Moles cancel out. The only unit left uncrossed is grams of CaO, which that's what the question is asking me for. So now I'm going to get my calculator, get 5.93 divided by 100 times 1 divided by 1. You don't really have to calculate that. Times 56.08. And I get 3.32 grams of calcium oxide. Now for number 7, it says how many grams of FeS, right here, question mark, grams, will be produced when SA react with 6.7 grams of iron. 6.7 grams. Okay, so this question is giving the information in grams, asking us grams of another question. So it's grams, 2 grams. Remember, this kind of similar to 6b is going to be very long because we need to use a molar mass twice plus the mole ratio. But I'm going to take one step at a time, beginning with what was given to me, 6.7 grams of iron. Now I'm going to divide by the molar mass of iron, which in this case is just Fe. You see how there's no subscript behind it? So all I need is to just look for iron in the periodic table, 55.85. I do not need to multiply it by anything. Okay, so it's just 55.85 grams of iron for every 1 mole of iron. Remember, the molar mass tells you how many grams are in 1 mole of that compound. The grams of iron are gone. I am left in moles of iron. And now that I'm in moles, now I could use my mole ratio. And the ratio here is 8 moles of iron for every 8 moles of FeS, iron 2 sulfide. The moles of iron are gone. Okay, I am left in moles of FeS. But the question is asking me for the grams, not for the moles. So I need to do one more step, in which I go from moles to grams, and I do that by using the molar mass. Let me do it here. Okay, so molar mass of FeS. So I have iron and I have sulfur. I have 1 of each because there's no subscript, there's no real number behind it. So the mass of iron, like we said before, it was 55.85. The mass of sulfur is 32.07. I add them and I get 87.57 grams per mole. This number, I'm going to write it in the top. 87.57 grams of FES for every 1 mole. Okay, in 1 mole of FES, if I were to put that in a scale, the scale will give me 87.57 grams. Like this, moles of FES are gone, and the only unit left across is grams of FES, which that's what the question is asking me for. So my last step is to get my calculator, 6.7, divided by 55.85 times 8 divided by 8 times 87.57, and I get 10.5 grams of FES.